This is the second part of the web service authorization post. In the previous post, we have highlighted some of the challenges related to the authorization services, and we also explained how a generic approach based on open specifications can save lots of efforts and provide a clean and decoupled implementation for authorization requirements for web workload in general, and more specifically for the web service implementation. Also in the post, we have explained the different authorization policies, including the user-based access control, the role-based access control, the time-based access control, the custom logic or the script-based access control, as well as the context and aggregated. And we have discussed a common authorization model where we define resources, policies, and set of permissions, which is combination of resources and policies, and also a high-level architecture of a resource server where you have the policy enforcement point and also the policy decision point, controlling all the traffic coming to your client application and getting the different permissions configured in the resource server. Today we are going to have a demo to realize those concepts and to show you how the authorization services can be easily configured in Red Hat Single Sign-On, and we will also show a sample Spring Boot application with zero code integration with Red Hat Single Sign-On. So this is Red Hat Single Sign-On. We will start by creating a rel, right? So just add a rel. So the rel already created, which is our authorization demo. And in this rel, we have different clients. So we'll create OpenID client. So if you click create, you just select the different types of the clients using the client protocol. For this client, we'll be using the OpenID Connect. So back to the API Service client. So this client is OpenID client with a set of other configurations. Right, more important for us is the valid redirect URI, means upon authentication or authorization. Upon authentication, once the GWT token is generated, then Red Hat Single Sign-On will redirect users to one of those valid redirect URIs. So our focus today is the authorization services. So we will need to enable the authorization services because it's configurable. You might need only authentication, not authorization. For our case, authorization services are required. So once it is enabled, you get the authorization tab. Under the authorization tab, you have the resources where you can define the resources. For our demo today, we have defined the admin resource and claim resource and user resource. Right? If you quickly look at, for example, the admin resource mapped to a URI, which is /API/admin, and the type is something we very generic we identify. For us, all the resources are URIs or URLs. Also for the claim resource, nothing but again /API/claim. So we have three resources we're going to use in our demo today: the admin resource, the claim resource, and the user resource. And also we have defined different policies, right? We have the admin policy, and if we look at the type, it is role-based. Here you can define all the different policies: the role, the JavaScript, the client, the time, the user, aggregated, and group. For the admin policy, if we click on the admin policy, it is role-based, and the role which is required here is the admin role. Okay, if we look at the user policy, it's again role-based policy. If we click on the role-based, right, it's a role-based policy. And here, by the way, you can search all the existing roles within the rel, right? And the role that's used here is the user policy. The most interesting part is the claim policy, which is the JavaScript-based policy. If you click on it, right, and you quickly look at the script. nothing but again checking certain attributes and make sure that there is a sum claim, and the sum claim, the value is 1, 2, 3, 4, 5, 6. And we will see how such policy can be used to simply introduce an API key for your REST APIs. So anyways, once a claim is provided with the value 1, 2, 3, 4, 5, 6, means grant access to the resources associated with this policy. Now, how do you link policies to resources? We go back to authorization. This is where we create the permissions. When you create a permission is nothing but a resource protected by a policy. So if you go back to permissions and create a new permission, resource-based, so you simply give it a name, description, and then search for the resources. We have, for example, admin resource, and simply select from the different policies we define. As simple as that. Okay, so in this, again, configuration, we have the admin resource mapped to API /admin. We have the user resource mapped to API/user. We have the claim resource mapped to API/claim. At the same time, we have three policies: admin role-based policy, and we have user role-based policy, and we have the claim, which is script-based policy. And also we created the three different permissions for admin, for user, and for the API key. Okay. So the next thing that we need to look at the different roles within the rel, right? If you look at the roles, we already defined a user and admin role. Again, you can anytime just create a new role, which is nothing but a name and description, which is optional anyways. So in our demo, we're going to use the admin and user role. And also the last step here is to create enough users and map users to role. So if you go to users, right, we have two users, Alice and Wael. If you click on Alice user and go to the role mapping, so Alice is mapped to user role, okay, while the user Wael mapped to admin role, okay, that's it. The next step is to create the Spring Boot application. For those are creating or working with Spring Boot, it's a very straightforward application. We'll just create a REST controller where we expose three different endpoints, one of them for the API/admin, another one API/user, another one API/claim. So let's quickly look at the controller. How does it look like? So this is the application controller. It's a straightforward REST controller where we mapping the API/user, API/claim, API/admin, exposing three different endpoints. And if we run the Spring Boot application, and then open the browser to hit API/user, we can see that users have access to this resource, also the /admin, then /claim. You have the access to these three different endpoints. So let's stop the Spring Boot application. Now the magic is just enable the Red Hat Single Sign-On dependencies in your BOM file. So just open the BOM file, and here the dependencies, three different dependencies. Just enable them. So we have the Keycloak Spring Boot starter, and then we have the authorization client, and we have the HTTP client. The three dependencies are required for the Spring Boot Red Hat Single Sign-On integration. And then we go to the application properties file, right? And this is the, again, the minimum configuration required for the Spring Boot application, where we have the server port number. This is where the Spring Boot application starts, right? And then we will add the Keycloak different properties. So the first thing is the realm, right? We have seen the realm in Red Hat Single Sign-On. If you go back to the Red Hat Single Sign-On. We created one realm, which is the auth demo. The second, again, important parameter is the authorization server URL. This is the URL where the Red Hat Single Sign-On server will be running. And the resource is the client, right? The client ID. If we go back to the clients, and we have one client here, which is the API service, right? This is the client ID. And then the next parameter is the secret. This is the client secret. This is something, again, for every client, the credentials, we have the secret. So this is how we tell the Spring Boot application that we need all the services protected by this application to integrate with Red Hat Single Sign-On in the auth demo realm under the API client using the client secret. And then we come to the three different endpoints we created, which is the API admin, API user, API claim. And also we need to define the different roles. And one important configuration here is the claim, right? This is where we have the script-based authorization role. So what we do here is simply map the claim policy, right, into a kind of API key parameter. So using this claim information point configuration, we simply mapping the some claim scripts created in Red Hat Single Sign-On into a request parameter API key, and the value as configured in, we go back to authorization and look at the policy and look at the claim. So the value will be 1, 2, 3, 4, 5, 6. This is simply how we integrate the Spring Boot application with Red Hat Single Sign-On. So if we go back to our terminal and start the Spring Boot application, and then try to hit the different URLs, including the claim. So the response will be again HTTP error 403, which is again a authorization error. Means this user does not have access to the resource. The same for the other resources, including the /user, user/admin. So what we need to do now, right? We will need to hit the Red Hat Single Sign-On OpenID token service to generate JWT token, and then call the different endpoints using this token. So for this, let's quickly use some scripts we prepare for the same, right? So we will use the curl, right? So this is a curl call, right? And this is the OpenID connect token, which is again under the auth demo realm. And we need to provide the authorization basic, the client name, colon, client secret, but this has to be encoded, base 62 encoded. We'll show you later in the text, right, how this base 64 string can be generated. And then we need to provide the username and password, and grant, again, type is the using the password. We're extracting the access token. If we just take the copy this and go back to our, and we hit this. So as you can see, now we have the JWT token generated. So to quickly validate the token, we can go to the JWT IO, paste the token here, and you can see that the token is decoded, and we can see that, okay, the different again token attributes, including the again the session state and the allowed origins, which is again the redirected URIs and the different attributes, and also the again some of the client details. Okay, good. The sorry, the user details, including the username and the user profile details. So once the token is generated, so what we need to do is to use this token for the subsequent calls to the endpoints as, again, mirror token, right? So if we look at the subsequent calls, right, after we generate this token, is to simply call the endpoints, including the user or whatever, using this mirror token. So if we quickly run the script, test script. Very good. So the green indicates access, right? That this user has access to the resource, while the red indicates the 403 or the user does not have access to this resource. So looking at the, for example, the first user Wael, trying to access the API user, and we can see that user doesn't have access. Based on what? Let's go back to the user Wael and look at the role mapping. Yeah, we can see that Wael does not have access to the API/user because he's not assigned or mapped to the user role. Let's grant him access by mapping user Wael to user role. So add and go back to our scripts and run them again. We can see that now user Wael has access to API/user. If we go back and again revoke permission by removing user role and run the scripts again. So back that user Wael doesn't have access, while user Wael has access to the API/admin. Yes, because he is mapped to the admin role. Now coming to the magic, which is the API key. So why user Wael has access to the API claim that is expecting a query parameter. Let's go back to the script and quickly check it. Yeah, we can see that while we are passing the bearer token, we also passing the API key equal 1, 2, 3, 4, 5, 6. And this is why this user having this bearer token has access to the API claim, because there is an extra check to be done, which is the query parameter API key, and the value has to be 1, 2, 3, 4, 5, 6. Let's provide the wrong value, add one extra one to the end of the value, and run the scripts again. Here. We can see that user Wael now doesn't have access to the API claim because simply we provided the wrong API key. If we provide the right key, which is 1, 2, 3, 4, 5, 6, yes, we can see that user Wael has access to the claim API. We can do the same by changing the expected claim value in the authorization settings here. If we go to the policy and go to the claim, right, and change it to, let's say, 1, 2, 3, 4, 5, 6, 7, save, right, and go back to our scripts, trying to test. Yes, we can see that again, because it's invalid key, user doesn't have access to this protected resource. So let's take it back to where and give it a try. Good, everything works fine. While, for example, user Alice, yes, has access to API user because simply Alice is mapped to user role, and doesn't have access to admin because user is not mapped to admin role, and for the claim probably there is a wrong API key provided. Let's quickly look at user Alice. This is user Alice, and this is the wrong value, right, provided to the API key. And also if you go back to user Alice, and do role mapping, to figure out that user Alice is mapped to only admin and not user. So this is simply how you can protect your APIs, providing full authorization capabilities on top of plain REST API developed in Spring Boot. And as we said, there is no single change needs to be introduced at the code level. As we can see, our REST controller is plain Spring Boot code, right? While all the configurations are done in the application properties